So welcome everyone. Thank you so much for joining us. My name is Christine Girardi, Assistant Curator of the Niagara Falls History Museum, and welcome to Not at the Museum Thursday night. And as usual, I would love to begin our program with a land acknowledgement. So the Niagara region of Ontario is located on the traditional shared territory of the Anishinaabe, Haudenosaunee, and Chinootan peoples. The Chinootan people have called these lands home for thousands of years, and more recently, the Anishinaabe, Haudenosaunee have been sharing the lands as one dish, one spoon treaty territory. Each night, the stars reveal the entire universe. The ancients describe them by the myriad of myths of the gods and place them in the sky to remind us of our mortal limitations. Too few people spend a moment to look up, but with COVID restrictions, people are looking for new interests in their own backyards. What better time to begin your understanding of the night sky? Tonight we welcome Dr. Brian Pihack from the Niagara Centre of Astronomy. He will take you on an extraordinary tour of the heavens over 2 presentations. If you missed last week's presentation, not to worry, you can head over to the Niagara Falls History Museum's YouTube page and watch it there, and this presentation will be put up on YouTube tomorrow as well. Before I welcome Dr. Pihack to begin his presentation, just a bit of housekeeping. Following this presentation, we'll be opening up for questions. If you're joining us on Zoom, you can type your questions into the Q&A function. If you're joining us on Facebook Live, just add your questions to the comment section and I will monitor them. So our guest tonight, Dr. Brian G. Pihack, DC, is a local chiropractor, the past president of the Niagara Centre of Astronomy, and retired national representative of the Royal Astronomical Society of Canada. Dr. Pihack received his first telescope at the age of 12, and it has been a way of life ever since. So take it away, Dr. Pihack.
Thank you. Okay, tonight we're going to do a little bit of hop, skip, and jump. I'm going to try and include some of the sites that you can see this month, next month, and then into the middle of summer. We're going to throw in a couple of little curves here and there just to go on. Uh-oh.
That PowerPoint presentation is just being very difficult tonight, isn't it? How many times are we going to make you reboot it?
So you've got nothing at all on the screen?
No, we do not.
Okay, let's try that again.
There we go. Back up and running.
So we got the Mars rock?
Yep, we've got the Mars rock.
Okay, this was a picture sent back. I just said my internet connection is now unstable. So you still can hear me?
Yep, we can still hear you.
Okay, good. Here's this rock, and I want you to take a good look at it for a moment because this shows us how far technology really has gone. Okay, this shot was taken, it took light 16 minutes to get from Mars to the Earth. Now, this is the speed of radio transmission. So at 186, 300,000 kilometers per second, it still took 16 minutes to get to us from Mars. And you must realize that it was a robotic probe that autonomously took this picture and then sent it, and you can literally watch it on your phone. So you're getting a picture of a Martian rock from a planet sent to your phone, all robotically. So that's pretty impressive. So when you're watching some of these stuff on the latest rover they have up there, just take this all into account. Now, another little eye-opener. If we could take the Earth and stretch a rope around the equator and make it really tight so that basically it constricts the Earth very tightly. And we're to add either 1 meter or 1 yard, depending on how old you are, of course. The question I have for you is, how much above the surface of the Earth would that rope now be if we added just 1 meter or 1 yard? And surprisingly, even given the size of the Earth, the answer is if you added 1 yard, the rope would now be 5 3/4 inches above the surface that it started with. If you added 1 meter, it would be 15.9 centimeters. So just by adding 1 meter to the circumference of the Earth, you would literally increase its surface or its diameter by, or sorry, circumference by 5 3/4 inches per yard, 15.9 centimeters per meter. One of the questions that I did get asked from somebody was, why do we see stars twinkle and how come they do twinkle? Well, the answer has actually got to do with the atmosphere of our Earth. Right here we have our Earth and we have our atmosphere. When stars are on the horizon, because the light takes a longer path and it comes through more atmosphere, the atmosphere moves around quite a bit, and this actually causes the light to bounce around a bit. Now, I've got a video in just a moment to show that. When the stars are directly overhead, like for example, the North Star or some of the stars of the Little Dipper, they don't seem to twinkle as much because the light coming from them comes straight through the atmosphere and there's not as much distance, so the movement becomes much, much less. Now, this star we're going to look at is called Sirius. It's the eye star of the dog constellation Canis Minor, and right now it's the brightest star in the sky. When it gets dark on a clear night, if you look off towards the west for about the next couple of weeks or so, this bright star will be quite obvious. It's Sirius, and I put the sun next to Sirius here to show you how really big it is. These are some still shots that were taken of Sirius, and the fact that Sirius is a blue-white star, these should all be blue-white in color, but our atmosphere attenuates the color somewhat and gives us all these different colors of the star. Now here's the star taken through a telescope. The telescope is not moving. It is basically the starlight that is bouncing around through the atmosphere, and you can see how much it does move. Now the X in the middle of the star is an artifact. This is because of the type of telescope that was used to film this. And again, somebody looking at this, seeing it bounce around a little bit in the sky, might misinterpret this as a UFO, especially if you get up a little bit closer. And whoop, where did our video go? There we go. This is a, well, it should be a video. There we go. This is taken through a stronger eyepiece, so we're going to get a much more magnified view. The star is bouncing around and it's very tortuous. This is what causes the twinkle in stars. It's actually the Earth's atmosphere. Now, the atmosphere also absorbs some light, some of the spectrum down towards the blue end. So when the sun is on the horizon or the moon, say during a sunrise or a sunset, it will appear red because all the blue, yellow, green is absorbed by our atmosphere, leaving just the red. And this is why we have these really beautiful sunsets. Now, May 5th is coming up next month, and this is another very interesting date. There are 8 dates that are tied to the ancients. On May 5th, we have all kinds of events, everything from Kubla Khan to Napoleon to the Three Stooges. But more importantly, throughout the world, it is a day of festivals. We have everything from May Day in Europe to in Japan, where we have Children's Day. Now here is our Earth as it's going around the sun. We have all of the months out here. The more famous cross-quarter date is right here between October and November. This is exactly halfway between the equinox and the solstice. This is Halloween. And when Roman Catholicism came up through into England, they took the nights of Halloween and turned them into All Souls Day, All Saints Day. December, of course, the solstice. The day of the solstice back 2,000 years ago would have been somewhere around December 25th. February, which is halfway between the solstice in December and the equinox here, is Groundhog Day. So our Groundhog Day is actually a cross-quarter date, which is exactly halfway between the solstice and the equinox. In August, we have the civic holidays, and between March and April, March 21st and June 21st, we have May 5th. And in Europe, this is celebrated as May Day. Now, again, we have the diagram here, or the picture here. We have our sun at sunrise. During the summer, it has moved the farthest north of east on June 21st. It's also going to be highest in the sky. After June 21st, the sun will rise continuously closer and closer to the equinox until it arrives on the equinox due east. It'll rise, and then as we march towards December 21st, which is the winter solstice, the sun will continuously move towards the south and rise a degree towards the south each day. And if we take the number of days between the equinox and solstice, which is roughly 94 days, half that number, it comes out to May 5th. So we can celebrate May 5th in that regards. Now, there's meteors, or incorrectly called shooting stars, because of course they're not shooting stars. There aren't too many happening up until we get into the Perseid meteor showers in August. But in the next month, around May 6th, May 7th, the night of the 5th, the morning of the 6th, sorry, there is a meteor shower where we have the leftover fragments from Halley's Comet. So if you missed Halley's Comet back in 1986, you can still see remnants as they plunge through the Earth's atmosphere. And pretty much any time after midnight is a good time to go and look, and we will see upwards around 40 an hour. And again, this goes on for a period of time. A week before, a week after, you will still see an increased number of meteors. Now, this is the Big Dipper that we have pictured here with all of the stars. Of course, if you want to test for your eyes, we're going to flip the dipper around so you can see it a little bit better, but we're going to look at this star right here in the crux of the handle. And the star is Mizar and Alcor. It's a pair of stars. The one star is very much brighter, and the other star is a little bit dimmer, but it sits off at about 11 o'clock. And if your eye on a clear night can actually discern the two stars, then you have pretty much normal to really good vision. You'd be surprised how many people, as they get older, can't see the split in the stars. Now, to find the North Star, which is an indication of where north is geographically, we take the Big Dipper and we take the two stars in the bowl of the handle, go in a straight line all the way down, and then we have Polaris. Now, Polaris is not the brightest star in the sky. A lot of people are misled by this. It is just an average star, but there's not too many stars around it, so it does stick out a little bit. But realistically, it's not any brighter than the rest of the stars in the area. Now, our Earth spins on its axis once every 23 hours and 56 minutes. It also makes one trip around the sun every year. That will cause the Big Dipper to move around a little bit in the sky. On a daily basis, the Big Dipper itself will move once in complete 360 degrees every 23 hours and 56 minutes. As well, you can see here from spring to summer, as we move around the sun, the Dipper will also change its direction as we go around. Now, this is due north here. Here is our horizon. And right now we have the Dipper up high. And again, the two stars here pointing to Polaris, the handle of the Little Dipper. And you can see here another representation. Here's the Big Dipper moving around the North Star. This happens again once every day, and it takes a whole year to go around completely as well. Here's the stars in the Little Dipper, and it's a good indication of telling how dark your sky is. Now, these numbers are what astronomers call magnitudes. The larger the number, the dimmer the object will be. So you can see that over here, Polaris, the North Star, is a magnitude of 2, which is fairly bright, but not overly bright. And the other star here in the box, or the Dipper itself, Kochab, is as well too. There is an easier way of telling how good your sky is, and we'll get to that in just a minute. The number of stars can give you a really good idea of the darkness of your sky. Again, 7 stars, if you see all of them, then you're at an excellent site for looking at the night sky. The easier way is this. If you see 2 stars, basically the ones at the end, we have Polaris here and Kochab. Oh, there's our Big Dipper pointing the way. The sky will display about 40 stars. And if you ask people how many stars you see in a sky, they will often very much over-exaggerate. Again, no fault of their own. It's just the way the sky does present itself. But if you see 2 stars in the Little Dipper, chances are you're only going to see about 40 stars through the entire sky, horizon to horizon. And the test, of course, is that the nearest Tim Hortons is probably 50 feet away. If you now see 3 stars, the sky will display about 140 stars. So by seeing one more star in the Dipper, we get about 3 times the number of stars through the heavens, and the nearest Tim Hortons is probably about a mile away. If we see many more stars, up to the point where we see 6 of the 7 stars, the entire night sky is only going to display about 450 stars if we're out, say, at Fireman's Park or out at Fort George. The nearest Tim Hortons is probably, give or take, about 5 miles away. And if you're lucky enough to see all 7 stars, this is the finest night sky you can hope to see. We'll see about 1,400 stars in total on average through the sky from horizon to horizon. And of course, you're probably quite a distance away from the nearest Tim Hortons, somewhere out where it's nice and dark, possibly out in Wainfleet, some area. Now, jumping ahead to the summer, there are 3 stars that are going to make themselves very apparent, and they form a triangle called the Summer Triangle. They are Vega, Deneb, and Altair. Now, just as the sky is starting to get dark, so it's moving from its nice light bright to a bit of a gray, blue, possibly still a little bit of backlight, these 3 stars will be the first 3 to jump out at you. And they're kind of incredible. Here they are here. I've got them lined up. These are all taken, of course, by a telescope, all from Earth, obviously. But take a look at them. Altair, the star on the left, which is in part of the Eagle constellation, is about 10 times brighter than our sun, but it's 17 light years away, which means the light that you're seeing come from Altair left in 2004. And to help you remember when that was when the first National Treasurer came out. The National Treasure movie, the Master and Commander movie came out, and Secondhand Lions. So when those movies came out, the photons of light left the star Altair and began their trip towards Earth. Now, Vega, which is the brightest star in the summer months of the night sky, it's in the constellation of Lyra. It is 30 times brighter than the sun and lies about 25 light years away. So that's roughly, give or take, 1996. That's when the movie Mars Attacks, Independence Day, and Twister came out. And here's our monster, Deneb, part of Cygnus the Swan. It is 54,000 times brighter than the sun. But it looks about the same in brightness as the other 2 because it's also 1,400 light years distant. Now, when I did a search for movies for 2004 and 1996, they seem to pop up quite regularly. But when I did a movie search for 1,400 light years ago, it came up with the world's population is only about 208 million people, and there were no movies at that time. No surprise there. Stars, Deneb, Vega, and Altair. We show you the size of them. Monster Deneb, okay, 54,000 times brighter than the sun. You can see why. There's the size of the sun compared to Deneb. Vega, the brightest star in our summer skies, 25 light years away. It spins so fast that it actually takes on this egg shape because it's spinning in this direction quite violently, and it actually flattens it out. Just about 5 or 6 times brighter, give or take, than our own sun. Then we have Altair, pretty close to the same size as our sun. And again, these 3 stars will become quite evident just as the sky loses its brightness in the summer months. Now, this is the Andromeda Galaxy. Unfortunately, we really can't see it until late into the evening when it comes up off the northeast horizon. But through a telescope, Glenn Podsadnik took this picture from Crystal Beach. And here's what galaxy looks like. Now, all of these other stars here that you see are stars in our own galaxy. We're peering through them very much like raindrops on a pane of glass, and we're looking at this galaxy. Galaxies are super cities of 400 billion plus stars. In the center, we have a supermassive black hole, and this is a nice representation of a galaxy. Now, our Milky Way galaxy looks a little different. We have this sort of flattened out bar-like center where we have a supermassive black hole in the center, and the sun sits out about 26,000 light years from the center. So somewhere around this, where this star is placed, around 26,000 light years from the center. So what we're going to do is look at what would happen in the summer months if we look into this direction. And because there is so much here, there's the nucleus, there's all of these arms. This is all very old stars. The young stars are at the very edge. We do see some beautiful nebulas from stars that have blown up. Now, looking at the due south horizon, middle of the night, middle of July, August sometime, you'll see two constellations. This is the teapot, called Sagittarius, and this is the Scorpion. And the center of the Milky Way galaxy actually is right about here. So if you can imagine some steam coming out of the teapot, right about there is where the center of the galaxy is, 26,000 light years from us. And you can see in this simulated picture that we're looking at the center of the galaxy, although there's a couple of arms of the galaxy between us and it, but still we're going to see an awful lot of objects. Now, Scorpius, right here, used to have a set of claws which were right here, but somehow, and we'll go through the story, the claws were cut off and it formed the constellation of Libra. Now, way back in ancient times, Babylonian, Egyptian, the scorpion did have these pair of claws. In fact, the two stars' names here are Zuben el Janubi and Zuben Ishamali, which basically mean north and south claw. And we had this beautiful scorpion, but along came the Romans, and Julius Caesar with his friends decided that Rome was so special it deserved its own constellation. So what they did is they cut off the claws of the scorpion and turned it into Libra. I guess justice for Rome, but injustice for the cosmic background. The bright star here is Antares. It's a red giant. And if you know a little bit about Latin, it's anti-Ramus, which means the rival of Mars. Now, when Mars is in this part of the world, part of the sky, the two of them are pretty much inseparable. They're the same color. So if you can see the red color of Mars, which right now is sitting in Taurus the Bull, and Antares, the two colors are very, very close. However, the sun that we have in our solar system is dwarfed by this giant. We can put 350 million suns in this giant red star. And you can contrast that with the fact the last time we met, we were talking about 1.3 million Earths fitting into the sun. Well, 350 million suns can fit into this red giant. Now, to get started in astronomy, you just need your eyes. And if you have a decent pair of binoculars, if you go outside, just sit again, middle of the summer, middle of the night, looking towards this area, and just scan here with a pair of binoculars, you will see all kinds of objects. And you don't really need a chart because a lot of them are so close together, they're very difficult to map out. Just enjoy them with a pair of binoculars or a telescope if you can. Here are some of them depicted on the sides. These are globular clusters, so these are millions of stars, all tightly bound by gravity. You'll find most of them up and through here. And then we have all of these other nebula in this area right here. If you're looking through a pair of binoculars, you will not see these beautiful colors. They will look just like gray, green, blue, gossamer blurs. But still, you're looking at stars anywhere up to 26,000 light years or less that have exploded, gone through the main sequence and caused violent explosions, populating the area with dust, dirt, and debris, which eventually will become future stars and planets orbiting them. There's also been a bit of confusion with moon phases, and I see or hear people telling me about them, and they're getting some of them wrong. So we're going to go over quickly the phases that we have with the moon. A new moon is between the Earth and the sun. You do not see it because of the glare of the sun, basically absent from the sky, and we call them a new moon. As the moon goes in an orbit around the Earth, it begins to just move away from the sun enough to start illuminating the sun side, and we get a waxing crescent. This is a crescent shape, and because more and more of it is becoming lit up by the sun, we call it a waxing crescent. And then when it's exactly 90 degrees in the sky, so basically at sunset, it is high due south, half of the side facing the sun will be lit, and we call it the first quarter. In the week following that, The bright side becomes more and more lit, and we call it a waxing gibbous because more than half of it is nice and bright, and it's becoming more and more until it gets across to this edge, which then it becomes a full moon. The full moon is exactly opposite the sky from the sun, so it will rise when the sun sets, and we get the full face-on view of the moon. And then we start the reverse. It's beginning to wane. It's beginning to lose its brightness, and it's a gibbous because it's more than half. And then we have the last quarter. And then past that, when we're heading towards a new moon, we have a waning crescent where the brightness is disappearing gradually. And now we have just a crescent instead of a gibbous. The crescent phase, moving towards a new moon in the week to come. And I thought it'd be kind of interesting to look at some of the structures on the moon that are quite easily seen. You don't even need a telescope for these. You can use just your eyes, or a pair of binoculars will work just as well. The big crater on the bottom is called Tycho. And we have the Sea of Tranquility, which of course has been made very popular by human visits. This is the area right here. Now these are Mari or Maria, and these are ancient volcanic fields that have filled, flattened, and cooled. We have Oceanus Procellarum, which is basically all of this area over here. It is the largest dark object that you will find on the moon. And we have Serenity, which is just one up from Tranquility. So we have Tranquility and Serenity. And if we have things that are tranquil and serene, sometimes we have a crisis. So we have the crises up here. We have Tranquility and Serenity, the three of them together. This is the Sea of Fertility, which you see on the very edge of the moon. And then we have the Sea of Nectar down here, just below the Sea of Fertility. We have the Imbrium, which is actually the largest circumscribed Maria from the face of the moon, also called the Sea of Rain. And then, of course, because up high is north and it's cold, we have the Sea of Cold, or Frigoris, right up on top. And then we're going to look at 4 craters. Now, the first one here is the brightest crater on the moon. When you look at it, even with just naked eye, you will see it nice and bright. This is the crater Aristarchus. And you can see in this picture how really bright it is. This is because of the debris that is inside the crater. Now, the crater itself is very, very large. If you compare, here we have the Grand Canyon, and here we have the edge of the Aristarchus crater, and you can see how much larger it is. And considering that the moon is only 1/4 the size of the Earth, this is quite a large crater. Now, it is called Aristarchus because of a gentleman way back 2,250 years ago named Aristarchus. He was the first gentleman ever to say that the Earth was not the center of the known universe, that it was the sun, and that the Earth actually moved around the sun and rotated on an axis once a day. Now, this is 2,250 years ago that this gentleman figured it out. And today we still have people that want to believe in the flat Earth nonsense. The next crater over is Kepler. And of course, Kepler is the gentleman who came up in the 1600s with the theories of planetary motion, which we still use today. So in order to get to the moon, we actually had to use some of his formulas to calculate accuracy. And we have Copernicus, which everybody should know. He was the gentleman who used Tycho Brahe's math and observations to put the sun at the center of our solar system, but do it with experimental science. He did a lot of observing, but he was afraid of the Catholic Church, so they never published his work until just about on his deathbed. And then we have the last crater over here called Eratosthenes, again from the ancient times. This is the very famous gentleman who, using shadows from the sun and a well in Egypt, was able to figure out that the earth was a sphere, that the sun was a sphere, and that he actually figured out the circumference and how far away the sun was fairly accurately. And he did all of this 2,300 years ago. Today with the Flat Earth Society, which just absolutely amazes me. Now, the next object you can see in the sky, although you should never, of course, look at it because it will hurt your eyes, is the star of our solar system called the Sun. About 99.8% of all of the mass of the solar system exists in the Sun. Quite obviously, it's the largest thing we have. It's about 70% hydrogen, about 28% helium, and a mixture of other little elements to bring up the percent. It's 150 million kilometers away. It's 1.4 million kilometers across. We can put about 1,300,000 Earths in the sun, and it rotates fairly quickly given its size. One day on the sun at the equator is about 25 days on the Earth. So it will take about 25 Earth days for the sun to spin just once on its axis. And it's about 5 billion years through its phases. When I ask people, we do public nights where we actually go out in the daytime with dedicated telescopes to look at the sun, and we will ask people, what is the sun? And their comments are usually a burning ball of gas. Well, it's not really, because there's no oxygen there, so it can't really burn. But what it does is it glows really well. So it is a glowing ball of plasma that's really, really hot in the center. And again, here we just put Earth up there to show you how really small we are and how really big the sun is. In the core of the sun, the temperature is absolutely crazy. It's about 15 to 20 million degrees Celsius. The pressure of all of that gas and plasma on top of you would be about 260 billion times the Earth's atmosphere. So right now, if you put your thumb out on your fingernail, you've got about 14.4 pounds of air sitting just on your thumbnail. Now it's a little bit less because we're possibly going to get some rain, so it's about 12 pounds, I believe, right now. But still, 12 pounds of atmosphere sitting on your thumb. Can you imagine 260 billion times that? Now, at that pressure and temperature, the electrons that you remember orbit the nucleus of an atom are no longer bound to the nucleus. So we end up with this stew of electrons, protons, and neutrons all just flowing around, which of course is plasma. And we should have... Now again, this equation is E equals mc squared, very famous, of course. What it means is that given a certain amount of mass, has of energy locked up in it, in the atom, in the electrons that are bound to the nucleus. Now here we have a real fancy chart, but basically this is just telling you that a bunch of helium atoms come together and they form a couple of hydrogen atoms, and a couple parts are left over, a couple of protons, maybe an electron here and there. These are converted immediately to energy. So we have a solid mass-like object of an electron or a proton or neutron that is suddenly converted right into energy. And it's done at an incredible rate. Every second, 700 million tons of hydrogen is converted into 695 million tons of helium, which means 5 million tons per second of matter becomes pure energy. And this has happened every day for 5 billion years. Now, to power up this star, if we took the most powerful nuclear device that humans have ever created, and we detonated 400 billion of them every second, that's the amount of energy that our sun produces on a regular basis. Now, the sun is 150 million kilometers away. To fly there in a normal 747 at the fastest speed it could obtain in atmosphere here on Earth, it would take 7,100 days or almost 20 years at the speed of a jet to get to the sun. Again, it takes light 8 minutes and 20 seconds, give or take, to get to us from the sun. And even at that distance, the effects are quite noticeable. If you spend too much time in the sun, you're going to get radiated by the sun's light and give yourself a sunburn. This is a close-up of a sunspot. Astronomers like to keep things quite simple, so it's sun, hence a sunspot. However, black one that you see there in the center is 10 times the size of the Earth. And it's these magnetic storms that give rise to flares, that give rise to explosions of energy that come off of the sun that could invade the Earth's atmosphere, giving us the northern lights. The reason why the spot is dark, it's just a couple thousand degrees cooler than the rest of the sun. And here we can see a Saturn V engine. The brightness on the bit here is when the exploding gases are at its hottest, so they are at its brightest. And by contrast, this looks darker only because it's a little bit cooler than the energy coming out here. Here's another close-up of a sun spot taken, and a couple more sunspots. We haven't got very many spots right at the moment in the sun transiting because the sun is still in a bit of a quiescent phase. However, when it ramps up and starts becoming very, very active, we will see many, many more sunspots. And again, here's a picture taken by Alan Friedman from Buffalo. And on the left, you can see the orbit of the moon around the Earth, the distance, and compare that to the star you see in the center. And here we have the sun in proper ratios to all of the planets. Now a little bit on towards actually going out your back door and looking at some constellations. This is tonight at 9 o'clock if it's going to clear up, although it doesn't look like it. We have the constellation here we talked about last week of Orion. We have the constellation here of Taurus the Bull, Auriga. We have Gemini the Twins. We have the bright star Sirius. We talked about the brightest star in our sky right now being Sirius. It's about 9 light years away. You can find it by finding the hourglass of Orion, following the 3 stars in the belt over to this star right here. And this is the one that we showed you twinkling because of the atmospheric aberrations. And of course, we still have Mars between the horns of Taurus the Bull. Now, Mars in the successive months is going to start moving up through this way here. Okay, this is the end of April. It's moved from here over to here. Now, this is still at 9 o'clock, but the background is more bright because we're going to get more and more daylight as we move towards the June solstice. And we're going to change it now to about 10 o'clock. So our constellations have moved down as the Earth rotates, and Mars is now at the upper left part of Gemini, the Twins. Tomorrow morning at 6 a.m., if you're one of the type of people that like to get up early, we will have the moon just on the horizon at 6 in the morning, but we will have Jupiter and Saturn, 2 bright objects not too far distant, just above the southeastern horizon. Here we have Jupiter with 4 of its larger moons. This is Io, and this one is Europa. And if somebody was to ask me where I think we would find life first off of the Earth, it would be this moon right here. And of course, we have Saturn, the ringed giant, showing there. Here are the 4 moons again. Io has a phenomenal amount of lava and volcanoes caused by the tugging of Jupiter's gravity. And here we have Europa. It is surrounded by a water ice crust, and underneath it we have slightly warm, slightly salty water. So again, where life needs water to start, this is one of my best guesses for finding life off the Earth. Now here's a close-up done by the Cassini probe. And if there is water underneath and there might be possibility for life, it might look like this. I usually show this to the kids to demonstrate some unusual life forms, although this isn't that unusual. It's just the cartilaginous skeleton of a swordfish. We might find something like this, which is a real fish. This is a Chimenera, or maybe a ghost squid, or some of these other ones. Now, how big is Saturn from ring to ring? An easy way to remember is that if we put Saturn between the Earth and the Moon, On a given day, the rings would just about touch the Earth and the Moon at the same time. So next time you look at the Moon, just think if we placed Saturn there, the rings would touch both us and the Moon itself. Now heading off towards the end of May, we're going to be able to see Venus. It'll start coming up higher here off of the horizon. Right now it's too close to the sun to see. And as you can see, by June, Venus has started to approach Mars. And this is a picture of Venus. Venus is covered by an atmosphere that we can't see through with visual telescopes. This is without the clouds circulating around Venus. And we should have another picture. Here we go. This is what Venus looks like in a telescope from Earth on an average telescope. Venus takes about 243 days to rotate once on its axis. Okay, so one day is literally 243 Earth days. An impactor hit it a long time ago and slowed down its rotation. The orbit around the sun takes 225 Earth days, much quicker, of course, about 30% quicker than the Earth. And yet a day on Venus takes longer than its year. So if you were on Venus and could survive somehow, you could literally walk towards the west and never see the sun set. Venus is a very, very nasty place. The atmospheric pressure is 92 times greater than the Earth. This is because most of the atmosphere is. So if you remember me telling you that the weight of air on your thumb is between 12 and 14 pounds, if you're on Venus, it's more like 3/4 of a ton. It's also the hottest planet in the solar system. If you put your laptop on a rock, it literally would melt. And the clouds are full of sulfuric acid and carbon dioxide. This is real acid rain. The worst thing about Venus, of course, is that Mondays would last 243 Earth days. Looking at the north, we have our Big Dipper here. Use the two stars in the bowl to find Polaris. In the handle of the Little Dipper curves back towards the Big Dipper. Between the two, we have Draco the Dragon. If we follow the curve here, the arc in the handle, we can arc over to the bright star here called Arcturus in the constellation of Bootes. And on the west side, we have the letter 3, the number 3, the letter M or E, depending on your point of view, of Cassiopeia, Perseus, and we have Auriga over here. Looking towards the west, you can pick out the hourglass of Orion. The 3 belt stars point over towards Sirius, the constellation Canis Minor, the small dog. We have the large dog up here, Gemini on his shoulder, and we have the little rabbit hiding from the hunter underneath his feet. Looking towards the south, again, we have Orion shifting off this way, but we have this great big question mark that's backwards. This is Leo the lion, and in front of the lion, we have Cancer the crab, and behind him, we have Virgo. Looking towards the east, again, we have the Dipper arcing towards Arcturus in the constellation of Bootes, and the bear walks on the back of the lion, the backward question mark of the constellation there. So we're almost at Q2. This is our website you can go to and find out where we will be doing different events throughout the year whenever we can. We will be doing solar days where we look at the sun. We will be doing nighttime viewing as well with the big telescopes, and we'll be doing lectures and demonstrations at Heartland and Fireman's Park when we can, when COVID has pretty much finished up. You can follow us on Facebook as well, where they will be posting some of their pictures. This is a photograph from Phil Downey, who is our secretary. He did a beautiful job of the Orion Nebula and the nebulas just above them. So I will open it up to any questions that anybody might have.
Thank you so much, Brian. That was fantastic. Just like last week, very informative. So our attendees, if you have any questions, you can write them in the Q&A function. And maybe I'll ask a question just to get us started. So this might be a silly of a question, and perhaps I'm showing myself as a historian instead of a astronomer or scientific individual, but how do we have pictures of galaxies?
Well, when we look into the night sky, all of these stars, the nebulas, these are all inside our own galaxy. And in the background, you will find these little spiral objects that are very, very faint. And using more powerful light gathering telescopes, we can actually magnify these and look at them. There are two that are favorites of mine that are just off of the Big Dipper. They are the Messier 81 and 82 galaxies. One is face on, so we look at it like the edge of a dinner plate, and the other one is, or sorry, face on, and it is actually looking at the face of like a dinner plate. So you have your two orientations, and you can actually see these in the same field of view in the same eyepiece together. And when you look at them, you know that they're quite different. They have a spiral form to them. And literally in the center is a massive black hole that's got this entire grouping of stars spinning. And we have looked back almost, say, I could say 12 and a half light or 12 and a half billion light years to some of the earliest galaxies. But all of them contain billions and billions of stars.
Wow. But then how do we get an image of our galaxy when we're inside of it?
If you notice the pictures of the galaxy, I started off with Andromeda Galaxy, which was an actual photograph.
Mhm.
And then when I flipped and said, this is what our Milky Way galaxy looks like, you will realize it was an artist's rendering. We cannot see the outside of the house from inside our house. No, you're quite correct.
And how do we extrapolate like what exactly it would look like?
Well, we can measure distances to stars and start plotting them. And that's exactly what they did. They can look at different stars, realize their intrinsic brightness, then from that calculate how far away they'll be. Looking at other galaxies, we can sort of see what's happening in that galaxy and apply it to our galaxy and basically come up with an idea of what it looks like.
Okay. I've always wondered
Maybe
I've always wondered about that.
like a galaxy from edge to edge, our galaxy is about 200,000 light years. So a light beam takes 200,000 years to cross just our galaxy. So when you watch Star Trek and they're talking about quadrants, all of the best of Star Trek could ever do was basically fly around in 1/4 of our galaxy. The only ones, of course, to get to the other side or other part of the galaxy was it Voyager? That I didn't watch the show, I don't know, but I think somebody told me that somehow there was some perturbation and it was shot to the other side of the galaxy and it took them forever to come home, type of thing.
I'm going to show my nerd colors. They were thrown into the Delta quadrant.
Okay, the fourth quadrant, sure, why not? But again, like if you think about all the other Star Trek, that happened in just 1/4 of our galaxy. So they got that pretty good.
All right, we've got a bunch of questions here now, so thank you very much for answering my question. But I'll open it up to some other people. So Brian wants to know what causes some planets to have a tilted axis like Uranus, which is very tilted on its side.
Basically, a planetary accident. A large impactor would have hit the planet when it was formed on its side. It wasn't big enough maybe to spin it all the way around. It was just big enough to knock it over on its side. Our moon was formed when an impactor hit the Earth when it was forming and knocked a chunk of the molten stuff out into orbit around us. Um, all these other planets, they all have slight angles to them, and all because of impacts. Because when the solar system first forms and all of the rocky planets form close to the star, all of the gaseous planets form farther away, there's a lot of collisions. There's a lot of energy being imparted to the parent rock from all these collisions, which will superheat the rock and start it to melt, even though it's radioactive and melting in and in itself. So these are all impactors from the forming of the solar system that hit planets as they're forming and sort of knock them over a little bit on their side.
Okay, excellent. Amanda wants to know why is Pluto no longer considered a planet?
Oh, okay. Pluto is still a planet. It is just a special class of planet. Okay, if you drive around in a great big car, that's a full-sized car. If you drive around in a small little compact car, that's still a car, only it has the name compact. Okay, there are a lot of rocky bodies about the size of Pluto in our solar system. We've got one of them Ceres in the asteroid belt. There are several of them over around by where Pluto is. So we've not taken away the planetary status. We've just given it a special status of where they are either, you can call them planetismals, you can call them, a whole bunch of different names, but basically it's just describing a smaller type of rock that is bigger than everything else, but not big enough to be a planet. Pluto hasn't taken out all of the debris in its orbit where the Earth has. So we put it in these special little classes of planet. That's all. It's still a planet, just a special class of planet.
Excellent. Des wants to know, where's the best dark sky preserve for Niagara other than Fort George and Fireman's Park?
To go really dark, you have to go out. We go out around Wainfleet area. There is a map you can Google, and you just type in dark sky location, and it will show you with a sort of like a chronology of, or sorry, not chronology, like different colors set on top of one another, showing you where the darkest skies are in the Niagara Peninsula. It is getting harder and harder to find them. When I used to go up to Fort George or Fireman's Park, I could pick out the auroras quite easy. Now it's getting tougher and tougher. So finding a dark sky, it's not easy anymore. Plus, we also have the Starlink system of satellites up there, which Elon Musk is putting up. And there are several beautiful pictures taken that have been ruined by the reflection of sunlight from all of these thousands and thousands of proposed satellites in the night sky. So that's ruining it for us as well.
Yeah, and if anybody who's joining us tonight who didn't watch last week's presentation, Brian does talk about that in the part one that you can watch on YouTube. So, Brian has another question. Why do some planets rotate opposite of Earth and the majority of other planets?
Again, most likely, as in the case with Venus, the planet during its formation was hit by a impactor which prevented the normal motion that would have happened. Now, when we do demonstrations, I have this large hoop that I stretch lycra in, and then I throw a bunch of alleys into it haphazardly, and within a couple of seconds, they're all traveling around the same direction, and they're all spinning the same way. It's just a couple of crazy laws of physics that do this. So when you get everything spinning the same way and you have an impactor wallop one of the planets, if it's big enough, it'll slow it down, stop it, maybe even turn it in the other direction.
All right, we have a question from Amanda again. Could we create an atmosphere on Mars? And did Mars have an atmosphere in the past?
Okay, I'm going to guess she is asking this because she is hoping to have Mars colonized. We have an awful lot of other problems. The atmosphere on Mars would be the least of our worries. Um, the radiation on Mars is quite severe. Going to Mars is quite severe. In the last video, I actually likened it to getting a number of full-body CAT scans worth of radiation on a daily basis. If we could put an atmosphere, we could attenuate some of the radiation, but then we have to combat the fact that there's calcium perchlorate in the soil, and that stuff really likes to do nasty things to the human body. Could we put an atmosphere around Mars? Yes, there is one there already. If you look, you can actually see clouds on Mars. Again, we have other problems like dust that can destroy the atmosphere. Mars is only about half the size of the Earth. It doesn't have a really good massive core, so the gravity isn't as strong. So again, keeping an atmosphere on Mars can be quite tricky. And in fact, if you really want to colonize a planet, after listening to what I just said about Venus, I think the first planet we're going to colonize will be Venus. If you remember Star Wars, they have Cloud City. Well, if we could develop a floating city that floats on the heavy atmosphere of Venus at a certain height above the ground, we could actually attenuate all of the nasty stuff on Venus, and we could have a self-sufficient floating city
Wow.
because we'd be closer to the sun. We'd have better sunlight, water, plants we can get growing from the photosynthesis. It's quite doable, and I really believe that the first colony we'll put off Earth will be on Venus. But because Mars is such a movie phenomena, there is such this move towards colonizing Mars. It's really tricky.
What is the atmosphere currently on Mars made of?
I believe a light carbon dioxide. I can't quite remember the rest of it. There is moisture because there is cloud formation on Mars. Was it Perseverance or Curiosity actually had clouds moving in front of it?
All right. Anybody else? This is your last chance to ask a question of Dr. Brian. Um, we'll just give it a moment. No, looks like we're good. Everybody, those were some really great questions. Thank you very much to everyone who submitted a question. And thank you so much, Dr. Brian, for joining us for the past 2 Thursdays and creating these amazing presentations to kind of inspire us in this now another lockdown to go out in our backyards and just take a look up at the sky and begin to wonder a little bit more. So thank you so, so much. Oh, and we've got Amanda saying, thank you, very fascinating. And I would very much agree with that statement. So I think with that, we'll say good night. To all of our attendees, thank you so much for joining us. And just remember that every Thursday night, the museum is producing digital content and it is always free. So just take a look at our website. Some of it is live, some of it is pre-recorded. Take a look at what's coming up, and we'd love to see you out here another Thursday night.
And if
And
I could add just one more thing, sorry.
of course.
I guess I am also doing one for the Welland Library next Friday, I believe it is. I haven't got my calendar here, but I'll be doing something not quite the same because I never put the same presentation up twice in a row, and none of this is scripted. So if they have questions, I can just kind of go sideways very, very easily. But I believe it's next Friday. I'll be at Zoom meeting through the Welland Library, so you can get a hold of them and find out. And if you want to join up again, you're more than welcome, of course.
That's great. Awesome. So there you go, guys. If you haven't gotten enough of Brian yet in the past 2 weeks, then you can check him out with the Welland Library next Friday. So thank you again so much, Dr. Brian. We really appreciated your presentations, and I hope everybody stays safe and has a lovely evening.
Thank you.